Okay, so we did non-cyclic photophosphorylation and now we move to cyclic photophosphorylation. Cyclic photophosphorylation, it begins from photosystem 1 and it falls back to photosystem 1 because cyclic will begin from this step where you can see that the light is being absorbed. It falls onto photosystem 1. Okay? When it falls, what will happen? Of course, there is chlorophyll inside photosystem 1, so the electrons will be boosted to a high energy level. They will fall into, or they will be accepted by the electron acceptor Y. And then from there, they are again going to the chain of the electron transport carriers. ठीक है? अच्छा, एक और चीज देखो, ये जो आपको बता रहे हैं ना, ये देखो, this is the key. The key is telling you that this thick arrow represents electron carriers. तो इसका मतलब हुआ कि wherever you see these thick arrows, there's a thick arrow over here, there is a thick arrow over here, and there's one arrow over here. So wherever you see them, it implies that there are electron carriers over here. तो इसका मतलब यहाँ पे बहुत सारे ETC लगे हुए हैं, right? Over here also, and over here also. तो अगर light पड़ रही है photosystem 1 पे, electrons are being emitted, accepted by electron acceptor Y, going down the ETC, releasing energy, फिर उसके बाद again accepted by the electron acceptor X and again falling back to photosystem 1. और जब वो fall back होते हैं to photosystem 1 तो वो भी ATP बनाएंगे, just like ATP बनी थी किसमें? non-cyclic में. ठीक है? लेकिन in non-cyclic, neither the NADPH is formed nor the oxygen is formed, isn't it?
Yeah.
है ना? ना ATP बन रहा है, sorry, ना NADPH बन रहा है और ना ही जो है वो ऑक्सीजन बन रहा है. So both of them, दोनों का नाम क्या है? दोनों का नाम है cyclic photophosphorylation. इसका नाम ही बता रहा है कि ATP बन रहा है. और दूसरे का नाम क्या है? non-cyclic photophosphorylation. तो means के the end product is that the formation of ATP takes place in both, but they are a bit different. One of them is cyclical and the other is non-cyclical. ठीक है? One of them uses photosystem 2 and photosystem 1. ठीक है? One of them only uses photosystem 1. One of them involves the splitting of water. The other does not involve the splitting of water. One of them involves the production of NADPH. The other does not involve the production of NADPH. ठीक है? But one thing is common दोनों में कि दोनों ATP बनाएंगे क्योंकि दोनों का नाम ही क्या है? Phosphorylation. ठीक है?
For our cyclic version, is there like a diagram for that? Yeah, like.
Yes, there is.
Can I see that? You can non-cyclic, so I completely understand. I just want to look at cyclic diagram.
ये देखो cyclic का diagram थोड़ा सा मतलब लेकिन mixed है with the non-cyclic. इस तरह मैं बता सकती हूँ कि in this diagram.
Yeah, can you like do the like अपने cursor से वो?
ये जो है ना, ये जो triangle नहीं बना हुआ light brown color में, this is cyclic.
Yeah, I see.
और जो सारी lines, हाँ, and the rest of the lines that have been made in blue color, they are the flow of the electrons in the non-cyclical.
Okay,
Blue lines represent
where's the starting of the cyclic phosphorylation?
Cyclic, the starting of the cyclic is photosystem 1.
So photosystem 1, energy electrons are excited are excited because of the light, right? Light, so their energy is raised and they move up to the where do they move up? They move up to the electron
acceptor Y.
Electron acceptor, sorry. So then Y say then they move down to the left side to where?
They're again Y से भी ना, they are again going down to the chain of electron carriers. कहीं नहीं जा रहे, वहीं जा रहे हैं.
अच्छा, okay.
Electron carrier पे ही जा रहे हैं, हाँ. और वापस भी उन्हें photosystem 1 में आना है. Now look, you can see I have highlighted it with my red pen that the cyclic photophosphorylation starts from photosystem 1. तो ये start हो गया, ऊपर जा रहा है, ऊपर गया, electron acceptor आ गया, फिर chain of electron carriers, फिर chain of electron carriers, वापस photosystem 1 पे आ गया. बिल्कुल एक ट्रायंगल की तरह है, साइक्लिक ऐसे. photosystem 1, electron acceptor, again the chain of carriers, back to photosystem 1, ऐसे है. समझ आया नहीं?
Yeah, okay. So miss, which one is more efficient though?
Which one is more efficient? As far as ATP production is concerned, both are efficient. But then if you are talking about NADPH भी मिल रहा है तो फिर non-cyclic is more efficient. We'll do the comparison of both of these. Um, हाँ, this is for you. इसको पढ़ो थोड़ा सा clarity आ जाएगी concepts में.
Okay, so I get it.
ठीक है.
Yeah.
अच्छा, you should always remember when you are doing cyclic and non-cyclic के दोनों में ना who's the donor of electrons and who's the acceptor. तो cyclical में तो donor भी photosystem 1 है and acceptor भी photosystem 1 है. मतलब final आके जो मतलब हम ये तो कहते हैं कि सही है वो एक जगह जाके Y बन जाता है, Y जो है वो इलेक्ट्रॉन एक्सेप्टर बन जाता है, लेकिन फाइनल जो इलेक्ट्रॉन एक्सेप्टर है दैट्स photosystem 1 only. Why? Because see, if I draw the diagram like this, मैं दोबारा से बना रही हूँ, right? Let's say that this is your photosystem 1. तो यहाँ से light absorb हुई, going up. Now this is the electron acceptor Y, and then these are the chain of carriers. Again, these are the chain of carriers. ठीक है? तो अब ये journey है electrons की. Again. So the first electron donor is photosystem 1. And the final electron acceptor is also photosystem 1. हालांकि रास्ते में उनको इलेक्ट्रॉन एक्सेप्टर मिला था जो कि था Y. But then the final electron donor and the final electron acceptor and the first electron donor is both photosystem 1 in cyclic photophosphorylation. समझ आ गई ये बात या नहीं?
Yes, I get it.
You get it?
Yeah.
So what about if I ask you in non-cyclical? अब इस diagram को देखो और मुझे बताओ कि who's the first electron donor in non-cyclical? First electron donor in non-cyclical.
Who's electron donor in non-cyclic? So that has to start off with first electron donor, photosystem 2.
ठीक है. And final electron acceptor in non-cyclic.
Why say why? Wait, did you ask acceptor in electron in non-cyclic?
हाँ.
Why, nahi? Like the electron acceptor, why?
No. I'll tell you what it is. Just a minute. Have a look. थोड़ा सा इसमें डिफिकल्ट हो जाता है इस स्टेप पे.
Okay, NEBP, say, because that for the 4 electron that got excited, that went up to the electron.
हाँ.
Right. Say.
और जो फर्स्ट इलेक्ट्रॉन डोनर है ना वो भी इट्स नॉट द फोटो सिस्टम, इट्स एक्चुअली द वाटर मॉलिक्यूल. क्योंकि इफ वी गो बैक एंड लेट्स चेक कि उस डायग्राम में क्या था. इसको भी देख सकते हैं कि यू नो ठीक है कि क्लोरोफिल ऑक्सीडाइज होता है, लेकिन उससे भी पहले जो है ना, द वाटर मॉलिक्यूल इज स्प्लिट एंड व्हेन इट इज स्प्लिट इट रिलीजेस इलेक्ट्रॉन्स। ठीक है, वो आपको डायग्राम में नजर आ रहा है, but I think I should have told you this before. That's why you couldn't, tell me. You can see कि इस diagram में नजर आ रहा है कि the water molecules they are being split in the presence of light, and when they are split, आपको नजर आ रहा है 4 इलेक्ट्रॉन जा रहे हैं, right? So the first electron donor in non-cyclic. I repeat once again, the first electron donor in non-cyclic is water, and cyclic में तो हम सबको पता है कि cyclic में तो first electron donor भी जो है वो PS1 है, और जो लास्ट इलेक्ट्रॉन एक्सेप्टर है वो भी PS1 है, ठीक है। लेकिन नॉन साइक्लिक का थोड़ा सा टेक्निकल है कि द फर्स्ट इलेक्ट्रॉन डोनर इज वाटर एंड द लास्ट डेस्टिनेशन, लास्ट इलेक्ट्रॉन एक्सेप्टर का मतलब होता है लास्ट डेस्टिनेशन ऑफ इलेक्ट्रॉन्स इज NADP। अच्छा, प्रोडक्ट को देख लेते हैं। द प्रोडक्ट्स ऑफ नॉन साइक्लिक आर व्हाट? ATP है, इट्स रिड्यूस्ड NADP, एंड द वेस्ट प्रोडक्ट इज ऑक्सीजन। Oxygen is a waste product of photosynthesis, and the useful products for cyclic are ATP only. There's no waste product.
Yeah.
है ना, cyclical सिर्फ जो है वो ATP बना रहा है। अच्छा, which photosystems are involved in non-cyclic? Both, isn't it?
Yeah.
Non-cyclic में PS1 भी involved है, PS2 भी involved है,
PS2 भी
whereas in
involved.
cyclical,
Only
in
PS1,
cyclic
PS2
only one.
Yeah.
हाँ, and what about photolysis of water? So
सही,
photolysis
वो
of
सिर्फ
water
non-cyclic में
जो है,
होता था to break down the water
हाँ,
to get the H plus, and in cyclic it's not involved at all. Yeah, that's perfect.
अच्छा अच्छा, I end here, but Abdullah, you tell me one reason कि why do you check your messages so late?
It's because I don't normally check WhatsApp that much.
So then what's the fastest way to communicate with you?
Miss, just call me on WhatsApp. जैसे आप message करती हैं ना, तो just call me at the same time.
Really? I should call you.
Yeah, just call me on
अच्छा,
WhatsApp. जैसे WhatsApp पे बस call करते हैं, like फिर वो my phone will start vibrating, so like I'll check. क्योंकि अभी तो miss you called me, तो I was in school. That's why I replied like what